Hi everyone, welcome to this video. So today I'm going to speak about watt hours, and I will give some concrete examples. My goal is really to give the simplest explanation as possible, so I hope that everybody will have a very clear understanding of the concept that I'm going to address today. So let's start with watt. When you talk about watt, you have to consider two main elements. So the first one is ampere. Ampere is the quantity of electron that go through a wire. So 1 ampere equals 1 coulomb per second, and 1 coulomb per second equals this quantity of electrons. Then you have the voltage. The voltage is the pressure that is put on the electrons while they go through a wire. And finally, you end up with watt. Watt is the power resulting from the quantity of electron and the pressure they have on them. So the formula is very simple. So watt equals ampere times volts. I don't know if at first sight this is very clear. So what I would propose is to give a very concrete and simple example to illustrate it. So let's imagine that you have a tube. This tube has a capacity of 1 ampere. So you can put a certain ball. The ball has a certain size. You cannot put a bigger ball. Then you have the voltage. So in this case, you can compare the voltage with the gravity. So the higher you will put the tube, the more voltage you will have. So it's very similar. So in this case, we have a fan, and the fan needs a power of 2 watt to start making the blades turn. So in this case, we have an amperage of 1 and volt of 1. So we result with a power of 1 watt. And so this will not be sufficient to make our fan work. So in this case, you have two options if you want to make the fan work. Either you increase the voltage, either you increase the amperage. So let's start with the first one. So you increase the voltage. So in this case, you see you still have the same tube, and so the same quantity of ampere, which is 1, but you increase the voltage. So in this case, you see there will be more pressure on the ampere, and so the blades will start running because we have a power of 2 watts. The second option is to keep the same voltage but increase the amperage. So in this case, you see you have a bigger quantity of electron that pass, but the pressure is smaller. So in this case, you also have 2 watts, and in both of these examples, the blade starts running. So I hope this was a clear explanation for watt. And now I'm going to talk about the distinction between watts and watt hour. So watt is the quantity of power that your device needs in order to work. So you talk about power. Watt hour is the quantity of power your device needs provided over a certain amount of time. So in this case, you talk about energy, because like this, you can use your device over time. So let's get back to our example with the fan. It will be very clear. So our fan needs 2 watt of power in order to function. So we have 2 amperes, 1 volt. So we have a power of 2 watts, which is sufficient to make our device to function. But if I provide 2 watts, our device will work just the time of an instant. So if I want to use my device over time, I will have to provide this quantity of power over time. So instead of this, it would rather look something like this. You see, you will have a constant flow of power, which is providing energy to the device. So very simple. Our device works with 2 watts of power. So if I use it for 1 hour, it will consume 2 watt hours. And if I use it only for 30 minutes, I will consume 1 watt hour. Okay, so now that we went through the watt and watt hours, I will present you some examples. So it will be easier to realize what kilowatt hour means in terms of real life usage. So if you have a classic light bulb, this one will require power of between 40 to 100 watts. Low consumption, it will be about 5 times lower. If you have a laptop, it will be 100 watt. A vacuum, it will be 1000 watts. So when you have 1000 watt, you say a kilowatt. A hairdryer will be about 1.5 kilowatt, and a dryer 3 kilowatts. So I think it's quite interesting to see that depending on the appliance, the consumption of electricity can be quite different. So for example, if you talk about the hairdryer, if you use it for 1 hour, you will have consumption of 1.5 kilowatt hour. So I mean, in comparison with the appliance and to what people would expect, I mean, the consumption is rather high. So I don't know, maybe if your roommate uses the hairdryer but you don't, maybe you would have some way to negotiate on the electricity bill. Then if we go through on the annual consumption of individuals, So in Switzerland, each inhabitant has a yearly consumption of about 7.5 megawatt hour. In the US, it's a bit more. They are about 10.8 megawatt hour of consumption in a year. So now to have some proportion between what devices need to run and how we provide them the power. I also give you some examples of electricity production. So if you have 1 meter square of PV installation, you will be able to capture between 150 to 200 watts. So in 1 hour, you will be able to do at the best 200 watt hour. Or wind turbines. So it really depends on the wind, the size, the location. You have many parameters which enter into account. It will be between 100 kilowatt and 6 megawatt. Now with dams, the biggest dam in Switzerland is La Grande Dixence. Actually, it's not a single dam, but a combination of 4 production sites. You're about 2069 megawatt. The biggest dam in the world is the Three Gorges in China. So this one has a maximum power capacity of 22,500 megawatts, which is quite impressive. I mean, if this dam is producing electricity at 100% of its capacity, in 1 hour it will be able to produce the yearly consumption of 3,000 inhabitants in Switzerland. So it's quite impressive, very lot. And then nuclear power, so it varies between 1,000 megawatt to 5 megawatts. And the biggest one is in Japan, which is about 8 megawatt, 8,000 megawatts. So guys, thank you very much for watching. I hope you appreciated it. I really did my best to give you clear examples with easy explanation. So if you could give me a thumbs up, I really appreciate it. So thank you for watching and have a good day.